All right, here we go into a couple of really good examples where you actually have to use logarithmic differentiation. This is where we have variable bases. So when you have bases, in this case, the bases in these two problems where we're going to be finding the derivatives, that are variables, or where there are variables involved, you cannot use the formula for y equals a to the u. So we cannot use, and by the way, that derivative, if you forget it, watch the previous video on it, it's video 2, that would be a to the stuff d stuff times ln a. We can't use that because, well, that ln a isn't a constant. So we'll see that in a second. So when I take a derivative of this, you have to use logarithmic differentiation. That means we've got to take the ln of both sides. So we'll take the ln of both sides, and when we do that, we've got that x plus 2 that's up there, that whole grouped value, is going to come out front. Sweet. So you get x plus 2 times ln of x. Now, the reason why we can't use the a to the u formula is right here. When we go to take the derivative of this, we're going to need the product rule. And there's no product rule involved in that formula. We need the product rule because the derivative of this is not just 0. It's not a constant. There's a variable. So when there's a base variable, or variable in the base, you must use logarithmic differentiation. Take the ln of both sides. Let's go. So I'll take a derivative of both sides with respect to x. It's going to be messy. Hang on to your hats if you're wearing one. 1 over y times y prime, or dy dx. We're taking the derivative with respect to x. That's equal to, we need the product rule here. First is x plus 2. D second is 1 over x. The derivative of x is just 1. Plus second ln x times the derivative of the first. Well, the derivative of x plus 2 is just 1. That's nice. So we get dy dx times 1 over y is equal to, and we'll smush this together a little bit, x plus 2 over x plus ln x. All right, now we're not quite done yet because we want to solve for dy dx. To do that, I'm going to multiply both sides by y. So I'll multiply this side by y and all of that John by y. Those of you that aren't from around the Philadelphia area, John is all that thing by y. So the y's divide out and you're left with dy dx equals all of this times y. Now, what I'm going to do in this last step is I'm going to replace y with what it is in terms of x. All I'm doing is copying. Y, oftentimes in these problems, your professor or teacher is going to want you to replace with what it is represented by in terms of x. In this case, it's x to the x plus 2, and we'll leave our answer like that. That is the derivative. It's gross. You must use logarithmic differentiation when you've got a variable in your base. All right, let's keep going. So this problem here, y equals cosine x to the 2x. So I'm going to take ln of both sides again. That's going to give me ln y equals, the 2x flies, soars over the ln of cosine x. And technically, I suppose that's got to be absolute value. We're not going to get into domain. We're just going to rock this out. But cosine x has to be positive here because you can't take the ln of a negative. All right, that's neither here nor there. We're going to take a derivative with respect to x. That's 1 over stuff, d stuff, which I'll write as y prime for a little bit of variety. I did dy dx here. I'll do y prime there. Now we need the product rule. So that's first, d second is 1 over cosine x. D second is times minus sine x. So that's first d second plus second ln of cosine x. D first, which is times 2. All right. So now we've got y prime. We've got 1 over y. Well, what are we going to do with that? I wonder. Well, let's neaten this up a little bit. I've got negative 2x. And this is essentially tangent x. Sine x over cosine x. Might as well write it in a simpler form, right? So negative 2x tangent x plus 2 ln cosine x. Now what I'm going to do is I'll multiply both sides by y. Okay, so we multiply both sides by y. We get y prime is equal to minus 2x tangent x plus 2 ln cosine x. All times the y value is going to be, well, what was y? This whole function here. So that's going to be cosine x, all of that raised to the 2x. And that right there is your answer, as it were. Again, we cannot use the formula for y equals a to the u and its derivative if you have a variable in the base. All right, logarithmic differentiation's got to be used. You take the ln of both sides and then differentiate implicitly. What's not implied is your skill. Once you know this stuff, it's going to be undoubtedly awesome. All right, I'll see you in the next video, integration with a to the u. Peace.